Hey guys, welcome to the second semester of Algebra 1. I hope you all had a relaxing Christmas break. We are moving on to Unit 9, which talks about exponents and polynomials. So we're going to start off with exponents and learning all the exponent rules, what happens when you multiply exponents, divide exponents, power to power, rational exponents, all the things with exponents this week. And I know it feels like we're jumping right back in and going pretty quick. We are on a pretty tight schedule with our EOC coming up in the spring, so we are going to be moving pretty quickly. So if you have questions, it is really important that you join me for tutoring, so make sure you schedule a time with me. That way we can keep on track for your EOC. So anyway, moving on with exponents, we're going to start by multiplying exponents. So first off, what is an exponent? You might hear the word power instead of exponent. These both mean the same exact thing. Power and exponent, same exact thing. And all an exponent does is it tells you the number of times the base will be multiplied by itself. So again, in this definition, we have the word base, and then we're talking about the definition of an exponent. These are the two key factors in a problem. So if you look here, the exponent is a little baby number. It's always raised up to a power. It is a little baby number up top. Your base is your big number. This is what you're going to be multiplying. So exponent tells you how many times you're multiplying the base, the big number. So again, this is our base. So if we started off with one that was 3 to the second power, my base would be the 3, that's the base, and the 2 is my exponent or power. And so what you do is you take the big number, that's what you're multiplying. This does not mean 3 times 2. No, that is not 3 times 2. This means I'm taking the number 3 and multiplying it however many times it says in that exponent, that baby number. So I'm taking 3 and multiplying it 2 times. So now I have 1, 2, 2, 3. So I take 3 times 3 and I get 9. So 9 would be the answer to this one. On this one, my base is this 2/5. It's a fraction, 2/5. So this is the only number I can multiply is 2/5. So I can't say 2/5 times 3. That's not what it's saying. I'm taking 2/5 and I'm multiplying it 3 times. So to multiply fractions, I go straight across. I've got 2 times 2 is 4. 4 times 2 is 8. Then on bottom, I've got 5 times 5 is 25. 25 times 5 is 125. So that would be 2/5 to the third power. Okay, so let's look over here at this chart. I've got 7 times 7. My base is 7. That's what's being multiplied. And how many times am I multiplying 7? 2 times. So that's my baby number. Base is the number that's being multiplied. The exponent tells me how many times. So 7 to the second power. Now, this one, notice I don't just have numbers. You can use exponents with variables, your letters as well. So I've got 4 times k times k. Well, 4 I just have one time, but the k's I have twice, right? So I'm multiplying k as my base 1, 2 times. So when you have this number out in front, you're just going to keep it out in front. And then I'm still multiplying it times the k, but this time I've got k how many times? 2 times. So this is 4k squared. Okay, so this time I'm supposed to write it out. I've got this 3 out in front, so I'm just going to put this 3 out in front here. Then I've got x. X is the base, but I'm multiplying x times itself 3 times. So it's 3 times x once, x twice, x 3 times. then I am also multiplying times y. And y is 5 times. So then I've got to multiply 1, 2, 3, 4, 5y. So that's written in that expanded form, and this right side is written in the exponent form. Okay? This one, I've got the 2 out in front again, so I've got 2 times I'm multiplying the x's are my base, and I've got 2 of them, times I'm putting this 3 out in front, and I only have 1 x, so it would just be 3x. If you have to the power of 1, if I just have 1 x, you do not have to put the power of 1 there. That it's implied that it's to the power of 1 if you don't put it there. So you would put it like this. And I know what you're thinking. You can simplify further. Some of you are looking at this and thinking, hey, I've got a 3 and a 2 here. Can I multiply those out? And yes, you can. We will get to that in just a second down below. But if you think you can simplify it, you can go ahead and try to simplify it. 2x squared times 3x. And again, if you wanted to simplify that further, you can. We're going to talk about that in just a second. I want you to try this next one on your own, doing it just like we did up here. I want you to write this in this using exponent form and just break it up using the numbers. Go ahead and pause the video, and then I will resume, and you can unpause it. Okay, so hopefully you've had a chance to work it out. If not, again, pause the video. I've got 8 out in front, just 1 8, times I've got the v's, so v, but I've got 2 of them, so it's squared, times 2 out in front. I only have 1 v over here, so it's v to the first power. Again, I don't have to put the 1 because it's just to the first power. And then times the w, but I've got 2 w's, so it's to the second power. So this one should be 8v squared times 2vw squared. And again, these can be simplified even further. We're going to talk about that down below. So if you look here, this problem is this one right here. Is the same problem we used up at the top. So if you look, they took it and used the exponents. I have 3 out in front. Then I have my 2 x's, so it's x squared, times I have my 2 out in front, and 1x. So what is the exponent if we don't have one? We already talked about that here. This is just to the power of what? 1. So we already talked about that. We can now simplify this further. We can simplify this further. I've got a 3 and I've got a 2. I can multiply those 3's and 2's together. So 3 times 2 would give me 6. So you can always multiply the numbers together. Numbers are gone. Now, I can also multiply the exponents together. So either using this or using this, I could multiply 3's and 2's and get 6, right? Numbers are gone. What you're going to do from here is, 1, you can look and see how many x's I have just from looking at this. Well, I've got 3, right? So this one tells me I've got x to the third power. If I were to look at it from here, again, I had the 6. The base is x. When you multiply exponents, this is the rule. It is on your formula chart. You add the powers. You add the exponents together. So you keep the same base and you add the exponents. So the exponents here is 2 and 1. So what I'm going to do is I'm going to add those exponents. 2 plus 1 gives me 3. So this is 6x to the third power, just like what we got over here when I counted all the x's. And that's what it says over here. So that's how you would simplify it further. So let's do this one. Let's start with this in expanded form and put it in this exponential form here. I've got my two numbers. I can multiply those together. 6 times 2 is 12. Then I've got my a's. So, I guess I should write this in exponential form first. Sorry. I've got 6. Then I've got my a's. So I've got a, but I've got 2 of them. So it's a squared times 2. I've got b's, and there's 3 of them. So it's to the third power. Sorry, I was trying to skip ahead there. Now I can simplify this even further. I can say 6 times 2, which is 12. Now notice A and B are not the same base. So I can't combine those and say I have A to the 6th power or B to the 6th power. They're not the same thing. So I can only say I have A, and again, it's only to the 2nd power. That's all how many A's I have, and B to the 3rd power. That's all I have. So I've got 12A squared times B squared, or B to the 3rd power. 12A squared B to the 3rd power. Okay, I want you to try this one. We'll write this out in expanded form, and then I want you to put it into this form over here and get it as simplified as possible. So if I were to rewrite this in this expanded form, I've got 7 times I've got 2 m's, so 1, 2, times I have 1 n, then I have the 2 times how many n's are going to go after that? 3. How'd you know that? The exponent tells me how many n's I have. So there it is in expanded form. So now I need you to find this form. So go ahead and pause me, and I want you to try and find that form. Okay, hopefully you had time to do that. If not, go ahead and pause the video. So from here, you're going to multiply your numbers. So I've got 7 and 2, which is 14. So I've got the 14 is the number up front. Then I'm going to move on to my m's. So I've got m squared, and there's no other m's there. So I'm just going to write out m squared. Then I've got, let me pick a different color here. Then I've got n and n cubed. Remember, if it doesn't have an exponent, it's implied that it's 1. When I multiply exponent, I keep the base. The base is n, right? That's the big number, or variable in this case, n, and I add the exponents. So my exponent is 1 plus 3, which should give me 4. So my exponent for n is 4. So there's my answer. Hopefully you're kind of getting the hang of it. If not, that's okay. We're going to keep doing it. So here we're just going to write it in order which we see it. Every time there's a number, we're going to break it up. So this time I've got -2. And all of this is going to go together. And then I've got the -5, which starts all of this. So I should have 2 things. So I'm going to have -2, 1c, 1d, times -5. But this time I've got 2 c's, so c squared. Then I have 2 d's, so d squared. And then I have 1 f. So it's just f to the 1st power, or just f. Then from here, I can take it a step further. So -2 times -5. Negative times a negative is a positive, so positive 15. Then I have c to the 1st power, or just c, and c squared. So again, just c is to the 1st power. I've got how many c's? 1 plus 2 is 3. Oops. So c to the 3rd power. Then I've got d, which again, if it doesn't have an exponent, it's to the 1st power, exactly. And then d to the 2nd power. I add the 2 baby numbers, the 2 exponents. 1 plus 2 is 3. So I have d to the 3rd power. And lastly, I have this little f hanging out. He's all by himself. He doesn't have anybody else, so I just add him on at the end. So this would be written in simplest form. That's how you multiply exponents. Again, we learned when we multiply, we do what with the exponents? Add. This is the rule. It's on your formula chart. Multiply, we add exponents. So look at, where's the first one? If we look at this first one, I've got a base of what? What's the big number? Big number base. Big number base. X is the big number. Okay? So I'm keeping that here. Then I look at my exponents. Okay? Those are the little baby numbers. Exponents. When I multiply, which is what I'm doing, I add those two exponents together. So 4 plus 7 gives me 11. So my new power should be 11. So there is my answer, x to the 11th power. Okay, look at this guy. What is the base, big number base? That is my m. Again, I'm multiplying. Notice it was written in two different forms. I had the little dot in between. That means multiplying. Parentheses mean multiplying. If I just have two things smushed together, that's multiplying. There's multiple different ways to tell that. Then I look here. My little baby number is my exponent. I've got a 3 and a 3. Remember, when you multiply, we add the exponents. So I've got 3 plus 3 gives me 6. So this is m to the 6th power is my answer. So not bad. I want you to try to do this one. So try to do number 3. Go ahead and pause the video. Okay. I'm going to go ahead and start. If first you need to identify your base, which is your big number. Oops. So in this case, I've got a base of r. Okay, then I'm looking at the exponents. I've got a 2, and there's nothing here. Remember, if there's nothing there, it's a 1, right? So now I have 2 plus 1 gives me 3. So it's r to the 3rd power is my answer. Good so far? Okay, let's make it a little bit more complicated. Again, we've already kind of been doing this, so don't freak out. This is exactly what we were doing up here in this table. Okay, you had all this stuff. We're just combining it all together, just like all of this. This is what we're doing now. Okay, so again, multiply the numbers first. Where's our numbers here? Okay, I've got a 4 and a 6. Multiply them out. 24. Okay, we're done with those. Done. Now I'm going to focus on the next letter. And I just go in order, alphabetical order here. So I'm starting with this x squared and this x to the 12th. Okay, my base is the big number. So my base would be this x. So I've got x. My exponent is a little baby number. And if I add those together, I've got 2 plus 12, which is 14. Okay. Then I'm going to the next one. I've got y's. So my base here is the y. If I look over at my exponent, it's the little baby number up on top. I've got a 3 and I don't have 1. If I don't have 1, I know it's a 1. So I've got 3 plus 1 is going to give me 4. So that is my answer. 24 x to the 14th power times y to the 4th. How are we doing so far? I'm trying to help you with the colors. I know it looks a little confusing. Some people the colors help, some people it doesn't. So if I need to not do the colors, let me know during class. Okay. So this one, all the bases are the same. All of the bases are x's. So that's my base. Then if I go to look at my exponents, those are the baby numbers. 2 of them don't have any, so it's a 1. Now I'm just adding 1 plus 7 plus 1. Gives me 9. So this is x to the 9th power. Okay, let's try this. There is no numbers to multiply. Since there are no numbers to multiply, I'm moving on to just the letters. So I'm going to start with a, because that's just the first thing that pops up. So I've got a times a. A is my base. Okay, so a is the base. Then if I look at the exponent, they both don't have any. If they don't have any, again, it's 1. So I've got 1 plus 1, which gives me 2. So I've got a squared. Then I'm moving on to b. So b is the base. That's the big number, or big letter in this case. I look at the exponents. I've got a 4 and a 2. I'm adding those two together. So 4 plus 2 is 6. And lastly, I've got this little c guy hanging out at the end here. He doesn't have an exponent, so it's 1. Oops. 1. And there's no other c, so it's just adding the c at the end. And there is, it's simplified. All the exponents multiplied together. So it's not too bad when you break it down. This is a snapshot of the formula chart. If you look at your formula chart, it looks exactly like this. It'll have this title, Properties of Exponents. It gives you all these rules. However, if you don't understand the rules, they're a little bit confusing. But if you just need a quick, oh yeah, I forgot, that's the rule for this. We are right now on product. Product means to multiply, which is what we're doing. Multiply, and right here it says the rule. If I have a to the m power, m could be anything. It could be 2, it could be 5, it could be 6, it could be anything. And a to the n power, well, you notice your base is a, so you keep a, and then you take your 2 powers and you do what? Add them, and that's what this is saying here. So it gives you a little refresher if you, if you needed to just remember that. So again, it's on the formula chart if you needed that refresher. Okay, so let's try a word problem here. What is the area of a square with a side length of 5x to the 3rd power? Again, Miss Miller is always going to do what first? Draw me a pretty picture. It's at a square, so there's my pretty square. It's beautiful. And it gives me a side length of 5x cubed. What is special about a square? All sides are the same. So if this is 5x cubed, then this is 5x cubed. And guess what? This is 5x cubed, and this is 5x cubed. All the sides are the same. So if I'm finding area of a square, area equals length times width, right? Well, in this case, my length and my width are 5x cubed. So I've got 5x cubed times 5x cubed. Now I'm simplifying. I've got numbers. Numbers always go first, so let's multiply those out. I've got 5 times 5, which gives me 25. Then I'm going to deal with the x's. The x would be my base in this case, so I'm keeping the x. And then I look at the powers. So I've got a 3 and a 3. I'm always going to add those powers together. So 3 plus 3 is 6. So the area of the square should be 25 x to the 6. And it's just units because we don't know what it is. But there you go. Okay, same kind of problem, same exact steps, except now what kind of shape do I have? A rectangle. I want you to do the same steps. I gotta have that pretty picture. I have to have it all labeled. You know how Miss Miller is. I've gotta have all that stuff. I can't just go from the problem to know what the answer is. So go ahead and pause me, and then we'll go over it once you have solved the problem. Okay, hopefully you've had a chance to solve the problem. If not, go ahead and pause the video, like I said. What is the area of a rectangle with a length of 10x squared and a width of 4x? So this time I've got a rectangle. That means I have two sets of parallel sides. I know that these two sides are the same, and I know that these two sides are the same, right? So I've got 10x squared, I'm going to assume that's the longer side, and 4x, and we'll make that the width. And again, I want to find area. I know that area of a rectangle is length times width. So this time, I know that my length is the 10x squared, and I know that my width is 4x. So now I can go ahead and plug in what I do know, which is I've got a length of 10x squared times I've got a width of 4x. Now I can go on to solving. Always multiply my numbers first. So 10 times 4, I have 40. Then I move on to my variables, my numbers. So I'm going to move on to x's. So I've got x and an x. That's my base. Then I look at the power, the little baby number, the exponent. And in this case, I've got a 2, and I don't have a number. Again, if I don't have a number, what is it? 1. It's implied 1. So I've got 2 plus 1 gives me 3. So the area would be 40 x to the third power, or x cubed, units. And there it is. That's multiplying exponents. The one takeaway from this is when we multiply the exponents, we add the exponents. That's the key takeaway. Add. Okay, that's the lesson. Bye, y'all.